Welcome friends to my channel Civil Lab. As I said earlier, today I am going to discuss some objective type question of strength of materials from Khurmi and Gupta book. So let's move on to the question. Question number 1. Whenever some external system of forces acts on a body, it undergoes some deformation. As the body undergoes some deformation, it sets up some resistance to the deformation. This resistance per unit area to deformation is called option A strain, option B stress, option C pressure, and option D modulus of elasticity. So friends, the correct answer is option B stress. Stress is the internal resistance force per unit area. If a body is subjected to some external forces, then the material will exhibit some resisting force. This resisting force per unit area is known as stress. So option B is correct answer. It is stress. Stress is resistance force by cross sectional area, and pressure is the exerted force per unit area. In this picture you can see this is the force and this is the body. So this force per this area is the pressure, but if this upward reaction, this reaction force per unit cross sectional area is known as the stress. So this is the difference between pressure and stress. So the option B is correct, stress. Next question is question 2. The unit of stress in SI unit. The unit of stress in SI unit, force per unit area. So it may be Newton per millimeter square, kilonewton per millimeter square, Newton per meter square, etc. So option A, B, C all are correct. So D is the right answer, any one of these. Question number 3. The deformation per unit length is called option A tensile stress, option B compressive stress, option C shear stress, option D strain. So the deformation of a body per unit original length due to some external force is known as the strain. So option D is the correct answer. Question number 4. The unit of strain is option A Newton millimeter, option B Newton per millimeter, option C millimeter, and option D no unit. So friends, strain has no unit, so option D is the correct answer. Strain is equal to, of question number 5, strain is equal to, number B is the right answer, del L by L, where del L is the change in length and L is the original length. Question number 6. When a body is subjected to two equal and opposite pushes, as a result of which the body tends to reduce its length, the stress and strain induced is compressive. Is it true or false? So friends, if a body is subjected to two equal and opposite forces, that is push, then the force induced is compressive. So option A is correct, true. Question number 7. When a body is subjected to two equal and opposite pulls, as a result of which the body tends to extend its length, the stress and strain induced is opposite nature of forces. It is pull, so tensile force. Question number 7. A body is subjected to two equal and opposite pull, P. So the body in this body the induced stress and strain will be tensile stress and tensile strain. Question number 8. When a body is subjected to two equal and opposite forces acting tangentially across the resisting section, as a result of which the body tends to shear off across the section, the stress and strain induced is, whenever a body is subjected to a force acting tangentially across the resisting section, then inside the section shear stress will be produced. So option D is the correct answer, shear stress and shear strain. Which of the following is a proper sequence? So friends, let me show you the stress strain curve for mild steel. This is stress, this is strain, and this is origin point. So friends, A, you can see a point is elastic limit, point B is upper yield point, point C is lower yield point, D is the ultimate stress and stress point, and E is the breaking final breaking point, breaking stress. So friends, the sequence will be correct sequence will be proportional limit, elastic limit, yielding, failure. So friends, proportional limit, just before the point A, so just before the point A, there is a proportional limit. After that you will reach elastic limit, then upper yield point, lower yield point, ultimate stress and breaking stress. So option, question number 9, option A is the correct answer. Proportional limit, elastic limit, yielding and failure. Hooke's law, question number 10, Hooke's law holds good up to, so friends, we all know that Hooke's law holds good up to elastic limit. In this curve you can see that, you can see elastic limit, the point A, and the Hooke's law is valid up to point A, elastic limit from O to A. So friends, for question number 10 it is option number B which is right, elastic limit. Or question number 11, whenever a material is loaded within elastic limit, stress is option A equal to strain, option B directly proportional to strain, option C inversely proportional to strain. We know that from Hooke's law, whenever a material is loaded within the elastic limit, the stress is always directly proportional to strain. So option B is the correct answer. Question number 12, the ratio of linear stress to linear strain is called modular of elasticity. Question number B is the correct answer. Question number 13, the unit of modulus of elasticity is same as that of, so friend, unit of modulus of elasticity is the same as that of stress, pressure and modulus of rigidity. Option D is the correct answer, and it is the it has the unit force per unit area. Question number 14, when a change in length takes place, the strain is known as linear strain. So in case of a body, if the change in length takes place along the longitudinal direction, then it is called linear strain. And you know that strain is the ratio of change in length and original length. So friends, whenever it is the change in length takes place along the linear direction, longitudinal direction, it is linear strain. When along the transverse direction, it is lateral strain. When the strain is about volume, it is volumetric strain. And shear strain is the corresponding strain due to shear stress. So friends, next question number 15, the change in length due to tensile and compressive force acting on a body is given by. Question number B, the change in length, option number B is the correct answer. Change in length del L equal to PL by AE. Question number del L, change in length del L equal to PL by AE. So friends, option number B is correct answer, where P is the tensile or compressive force acting on the body, L is the original length of the body, A is the cross-sectional area of the body, and E is the Young modulus for the material of the body. Question number 16, the modulus of elasticity for mild steel is approximately equal to. So friends, keep in mind the modulus of elasticity of steel approximately 2 into 10 to the power 5 Newton per millimeter square, or option number D 210 kilonewton per millimeter square. So next question number 17, Young modulus may be defined as the ratio of, as I said earlier, it is the ratio of linear stress to linear strain. So option C is the correct answer. Question number 18, modulus of rigidity may be defined as the ratio of, so friends, modulus of rigidity is the ratio of shear stress to shear strain. So option D is the correct answer. Question number 19, the unit of Young modulus is same as that of stress. Yes, it is true. The unit of Young modulus is same as that of stress and pressure also. Question number 20. Two bars of different materials and same size are subjected to the same tensile force. If the bars have unit elongation in the ratio of 2:5, then the ratio of modulus of elasticity of the two materials will be. So friends, let me show you. From Hooke's law calculation, we can see that del L inversely proportional to E, Young modulus. So friends, del L 1 by del L2 in proportional to E2 divided by E1. So friends, Young modulus E1 by E2 will be proportional to del L2 by del L1. So 5 by 2. So E1 is to E2, 5 is to 2, B. So friends, simply if the elongation ratio is 2:5, then the ratio of modulus of elasticity will be the opposite in ratio, because the elongation ratio is inversely proportional to modulus of elasticity of the material. So B is the correct answer. Number 21. When a bar of length L and diameter D is rigidly fixed at upper end and hanging freely, the total elongation produced in the bar due to its own weight is. So friends, you can see the picture. A bar of length L rigidly fixed at this point. This is a bar of length L and diameter D. So elongation equal to gamma L square by 2E. Is the Young modulus of the bar. L is the length of the bar and gamma is the density of the bar. So friends, question number 21, it will be the option B, which is correct. W equal to weight per unit volume of the bar or density of the bar. Next question is question number 22. The deformation of a bar under its own weight is how many times the deformation if the same body is subjected to a direct load equal to weight of the body. So friends, question number 22. For question number 22, the deformation of a body, we know that deformation of a body under self weight is WL by 2AE, where W is the self weight of the material or body. W is the self weight of the cell material of the or body. But if the body is subjected to a external force, direct load, suppose P, then the direct load then under the direct load the deformation of a body will be PL by AE, where P is the external force, L is the length of the material, A is the area of the material, and E is the Young modulus of the material. Deformation of a body under self weight WL by 2AE, and under direct load it will be PL by AE. For this question 22, the deformation of a bar under its self weight is half the deformation if the body is subjected to a direct load equal to weight of the body. So friends, if W becomes equal to P, then you can see, if W becomes equal to P, then you can see the deformation of a body under self weight is half of the deformation produced under the direct load, PL by A. Option B is correct answer, half, for the question number 22. Next question 23. The elongation of a conical bar under its own weight is how many times that of the prismatic bar of the same length. This bar is prismatic. So friends, see, when a conical bar of length L and base diameter D is rigidly fixed with its base and diameter at the free upper end and is hanging freely, then total elongation of the bar due to its own weight is given by del L equal to W L square by 6E. So friends, remember it. Whenever a conical bar of length L and base diameter D is rigidly fixed
with its base diameter at the upper end and hanging freely, the total elongation of the bar will be under its own weight will be WL square by 6e. We determined the elongation length for a piezometric bar of length L and diameter D for its self weight W. But when it is a conical bar, then the deformation or change in length will be equal to one third of the elongation produced for the piezometric bar. Remember it. So friends, for conical bar the deformation will be one third or the gamma L square by 6c. So friends, for question number 23, the option C is the correct answer, one third of the piezometric bar. For question number 24, the length of a conical bar is L and diameter of the base is D and weight per unit volume is W. It is fixed at its upper end and hanging freely. The elongation of the bar under action of own weight will be. So friends, the deformation or elongation of a conical bar under its own weight will be equal to gamma L square by 6c. So option C, W L square by 6c is the correct answer for question number 24. Next question is 25. Strain rotators are used to. So friends, strain rotators is a device used to measure normal strain at a point in a plane. It comprises 3 independent strain gauges, each of which used to read strain at the same point but in different direction. So friends, strain rotators is a device used to measure the strain in different directions. So option number B is correct answer, used to measure linear strain. Next question is 26. A bar of length L meter extends by L mm under a tensile force of P. The strain produced is in the bar is, so strain is equal to del L by L. So del L by L and capital L change in length small l divided by capital L into, if you convert this capital length L into millimeter, then you have to multiply it with 1000. So we will get 0.001 small l divided by capital L. So for question number 26, the option D will be correct answer. Next question is 27. The extension of a circular bar tapering uniformly from diameter D1 at one end to diameter D2 at the other end and subjected to an axial pull of P is given by. Let me show you the tapering bar. For this tapering bar, suppose this is a bar tapering from this end to descent to descent. This end diameter is D1 and this end diameter is D2. So friends, change in length due to axial pull or push, the elongation del L will be equal to 4PL divided by pi E D1 D2. E is the Young modulus, D is the diameter, D1 D2 is the tapering diameter, and P is the external force, and L is length of the bar. So friends, correct option will be C, del L equal to 4PL pi D1 pi E D1 into D2. Next question is 28. The extension of a circular bar tapering uniformly from diameter D1 at one end to a diameter D2 at other end and subjected to an axial pull of P is how many times the extension of a circular bar of diameter root over of D1 D2 subjected to the same load P. So friends, here the question is asked if the tapering bar is subjected to an axial pull of P of diameter D1 and D2 for the tapering section, then its change in length will be how many times the change in length with respect to the uniform circular bar of diameter root over D1 D2. So change in length for the tapering section we know del L equal to 4PL divided by pi E D1 into D2. And if we calculate the change in length for the circular tapering bar of diameter root over D1 D2, so del L will be equal to PL by AE, so which will be equal to 4PL divided by pi root over D1 into D2 square into E. So which will also be equal to 4PL by pi D1 into D2E. So both will be equal. So for question number 28, the extension of a circular bar tapering from D1 to D2 will be equal to the extension of a circular bar diameter root over d1 d2 subjected to the same load P. So option number A is correct. Next question is 29. The ultimate tensile stress for mild steel is always more than the ultimate compressive stress. Keep in mind, the ultimate tensile stress for mild steel is always more than ultimate compressive stress. Next, so option number C is correct. Next question is 30. The maximum stress produced in a bar of tapering section is at the which end? Smaller end, larger end, middle, or anywhere? Also remember, the maximum stress produced in a bar of tapering section will be at the smaller end, because the smaller end has small area. So if the area is small, the stress will be maximum. So the maximum stress produced in a bar of tapering section will be at the smaller end. So option A will be correct for this.